Hello students, welcome to the first module on IUAC PhD teaching series, module 628A. Today's lecture is on RS232 serial communications, theory and practice. At the end of this video, you will learn what is RS232, how a serial cable can be made between an instrument and a PC, how to read data from LAKESHORE temperature meter, which is a case study which we have given at the end, using different languages like C++ under Linux, then Python, then LabView and Windows GUI, then Qt GUI under Linux. How to make an RS232 transmitter, that will also be discussed in this module. That will be using ARM MBED Microcontroller hardware, and also you will learn how to design RS232 firmware using free ARM MBED Microcontroller compiler. Why serial communications? Serial communication is the most simplistic form of communication between two devices. It is what started the networking. Any communication between two parties need a protocol. Protocol is nothing but a well-defined rule or language between two parties. RS232 is a popular communication interface for connecting meters, scientific instruments, and data acquisition devices to computers. And it can be plugged straight into the computer serial port. In Windows, we call it COM port for the serial port, whereas in Linux, it is /dev/tty/s0 or /dev/tty/cua0, etc. As you can see on the screen, how serial and parallel communication take place. Parallel communication means it needs a wire for each bit. Suppose a character is made of 8 bits, it needs 8 different wires plus the control wires. So, when the source and the destination are more than a few feet, the parallel cables can be very bulky and also very expensive, and is very susceptible to reflections and induced noises are a big problem for long distance communication in parallel buses. Therefore, the serial I/O comes as a rescue and overcomes these problems. This is how the serial communication looks like. You can look at the screen, parallel to serial converter, again serial to parallel conversion. So, what is RS232? RS232 is standard by which two serial devices communicate. The connection must be no longer than 50 feet. The transmission voltages are approximately minus 15 volt and plus 15 volt. Minus 15 volt for one level, logic 1, plus 15 for logic 0. It is negative logic. It is designed for transmission of characters of either 7-bit or 8-bit in length. Therefore, RS232 standard defines electrical characteristics, timing, meaning of signals, and the physical size and pin out of connectors. You can see a cable which we have made to connect between my PC and an instrument which I have bought. You can see that 9-pin D connector on both the ends. On one end, that blue connector on the left hand side goes into the PC side, the right side one goes into the meter. A typical RS232 communication example looks like that. You can see a terminal is connected to a modem and data is going through a telephone line and it's brought back to a computer. This is a telecommunication example. This is not the example exactly for scientific instruments. Scientific instruments, it's much more simpler. There is no modem required for that. So the communication can take place from left to right as well as from right to left. Like in the case of an example in which in the picture you can see a laptop and a meter. Both the ways the communication can take place. Now it is an important aspect of RS232 that it is asynchronous. Asynchronous means the data may come once in a second or once in a day, and whenever there is no data, the connection sits idle. No additional CPU overhead is required in the serial line. How can you transmit data? RS232 communication is dependent on the set of timing speed at which both the parties communicate. Like if I speak very fast, the other person may not catch. So the speeds have to match. How do you do all this? So there is something called a start bit, which is a logical 0 sent on the line to tell the other device, I'm going to start transmitting, you start sampling. And the start bit is a logical 0, that is plus 15 volt. Every time a character is sent, the same communication occurs. A start bit is sent, then 7 or 8 bit of data is sent, stop bit is sent. Now, in order to talk, we have mentioned that both devices must have same speeds to talk, but they also must know to handle the problems. The transmission rate of serial devices is called baud. Baud is nothing but bits per second. Now, as you can see on the screen, whenever a character is sent, so many pulses happens through the wire. That's a start bit, then it's a data byte, send in 8 bits or 7 bits, then there's a stop bit, then there's a parity bit. Parity is the error code which is sent. When data is sent from one end to the other, is one level got corrupted as 0 or 0 level got corrupted as 1, that can be understood by the parity. You can see the binary numbers below this, the same representation of the pulses. Common serial settings. Most settings are read in the following form: bits per second, number of bits, parity, and number of stop bits. And a common protocol is a 9600 N81 is what you can see in most of the manuals of the instruments which you buy. Now, the first thing when you buy an instrument, you have to make an RS232 cable. So read the serial communication manual. There, you probably don't need to use all the 9 wires of a RS232 connector to make a cable. Most of the times you need 3 wires: transmit, receive, and ground. Now, in order to make a cable, you should understand certain basics. What is half duplex transmission? Data are sent in one direction only. It is very simple. It's like a walkie-talkie. You speak, any one person speaks at a time. So only one wire is required for that. When it comes to full duplex, data flows back and forth. You can see that on the screen. RS232, it is a full duplex transmission. And you can see how the transmit and receive wires are connected to accommodate that. Now, architecturally, RS232 is a bidirectional point-to-point link. You can see the connector which is on the PC side, RS232 connector with the 9 wires. You can see that among the pins at the bottom, the yellow marked ones, that is pin number 2, 3, 5 are only usually required to have a simple communication between the device and the PC. The others are called hardware handshaking signals, which are required in advanced RS232 applications which are not discussed in this tutorial. Now, in RS232, there are two types of connectors, DTE and DCE. DTE stands for Data Terminal Equipment, DCE Data Communication Equipment. For example, a modem, which is a DTE, transmits on pin number 3 and receives on pin number 2. And also you can see DTE connectors are always male connectors. DCE connectors are female. These are some standards. Now DTE DC communication, whenever it takes place, it is called a straight cable. You can see that receive goes to receive, transmit goes to transmit. Whereas a DCE DCE or DTE DTE communication takes place. For example, my computer is a DTE and my temperature meter is also a DTE. So I need to make a null modem cable which looks like that. Transmit goes to receive, then again transmit goes to receive goes to transmit. Now this is how a DTE pin diagram looks like. As I said, there are 9 connectors, 9 pins in the connector. You need 3 wires for the basic communication. Pin number 2, 3 and 5. Sometimes people use 25 pin D connector also for RS232. So then there is the pin numbers are to be remembered, which looks like that. You can see that in the screen. Now when you use DT communication, you have to have the null modem cable. If you wanted to use all the wires with hardware handshaking, you can have the same connections, but most of the time whatever you see on the rightmost corner down, you need only 3 wires for null modem cable. Now look at a telecommunication setup, how data is sent through telephone wires between a terminal and a computer. So you can see that how the DTEs and DCEs are configured in this communication system. Now one of the disadvantages of RS232 is the speed is limited, similar to the length of 50 feet. Now here 56 kilobits per second. Analog modems are pretty much fastest analog modems that consumers are going to see. The limitation is due to the telephonic systems, not the computer system. Telephones have its own capacitances, so it will reduce the speed at which the pulses can rise. So as you can see, how the pulse gets distorted when 1 level and 0 level is sent through wire because of the capacitances. Because of that, RS232 is limited to its speed. Maximum speed is 19.2 kbps, but I have seen people using up to 115-200 baud also safely. You can see other speed rates, baud rates, which are shown in the picture. 110, 150 up to 57, 800 is corresponding to 56 kbps. Now in order to send any data from any device or instrument and to be captured by a PC, you need to understand how the communication takes place. It's a message communication system. It is like I will ask, what's your name? Then the receiver replies, okay, this is my name. Same way, you have a set of commands which are pre-programmed in the firmware of the instrument. For example, KRDG space 1. Then the terminator character is carriage return. That is the question being asked by a computer to a device to read temperature value of channel 1. This is for a LAKESHORE meter. Then it will return the data. As soon as you send the command, it will return the data of the first channel. This is the same temperature meter which I am talking about. The first channel is showing 34.015 K. This is what it would have read when I asked this question. Now, the first thing what you do whenever you buy an instrument like Lakeshore or any other device is just look at the serial interface specification. First it will say it's a DTE or DCE, therefore you can make the cable accordingly, null modem or straight cable. So DTE, like in our case it is a null modem cable because computer is also a DTE. Now this supports speeds up to 9600 only. The protocol is like 701, odd parity and 1. Now the below is the picture how you connect it. It's a PC. Then some PCs don't have the RS232 port, so you use a Moxa U1110 converter, which can be used as a USB to RS232 converter. Then you can make a cable connect to the instrument. So the entire connection looks like that. This is the rear portion of the Lakeshore LS218 meter. You can connect the RS232 connector at the behind through a cable which you make, which is a DTE null modem cable. That is 2, 3 are interchanged, 5 is common. Then connect it to this Moxa converter and connect it to the PC. As soon as you connect it to the PC, a COM port will appear on the PC. Now, in order to test the cable, the first thing what you do is use a software called TerraTem, which is freely available in the market. Download that and you configure the serial port. What you see on the screen is a COM3. This baud rate is according to the device you bought, and all these things you set it, and after that the next screen, one more window, you can select the terminator characters. Like a receive, I have transmit CRLF, carriage return plus line feed. This is what is given in the manual of the temperature meter, how they have coded or embedded the terminator character inside the device. All those things you set. After that you get a screen, blank screen, where you can type in your question, KRDG question mark space 1, then enter. Then you get the reply from the first channel temperature will be read back on the screen. Now the program required to communicate the pulses which are going is all unknown to you right now, because this is somebody has made this program in certain language and given to the user for free of cost. But in practical life you need to build your own software that would be more convenient to log the data, analyze the data, etc. So all these details are given in the following videos. So let's take the example, how do you do the same thing through Python programming? How do you read the data? So you can see that you are defined COM2 with a particular board 9600. You define the protocol. After that you can say that there is a while one loop. You are sending a command KRDG question mark 1. Then also the terminator string /r and /n, which is nothing but the carriage return and line feed. Then you have a while loop. After you send the command, you sleep for 1 second. And mean the command is accepted by the device, it send back the characters. So while you can, the while loop will collect character by character and assemble into a string and give it out. And you will see the entire data is collected in out. OUT, that is where it will collect the string combination of all characters that will contain +480K or something like that. Now this is how the output of this Python program looks like when I interface my computer to the Lakeshore device. Now sometimes you don't have Python. Now if somebody has got Visual Basic, and Visual Basic program I have purposely given to demonstrate the concept more clearly. Here the same thing, whatever you did right now through Terratime or Python, is done through VB. You can see you are defined a port COM1, then you are asking here a question star IDN question mark. Star IDN means what is the name of the device. This is usually a RS232 command with most of the devices. After that, you can see that you asked a question. After that, you have to collect the data in a loop. So you have a do loop. In that, str value will contain character by character. They will be added and made as a string. That loop will go on collecting the data after you ask the question. So str value will contain the final temperature value of that channel. Then how do you read the RS232 port using C language under Linux? So in Linux, in Ubuntu or any similar versions of Linux, you can simply use a class called linserial, which is coming free. So this is simple C++ program using linserial. So you're creating an object out of the linserial class. That is what you can see, linserial star m is equal to new linserial. So through that you can set the port /dev/cua1 is nothing but, you can see it's like COM2 or something, and you can set the protocol like 701. After that speed. After that, in Linux everything is a file. The port is also a file. So you write into the file question krdg question mark 1. On the right hand side top you can see that it is printing into the file. So it is waiting for the answer to come back. Then when answer comes back, you scan it. Scan the string on the port. So finally what you get is in the buffer called S can store 200 characters. You can get the data into this. This is how you read data through simple C++ program under Linux operating system. You can compile this program using G++ test.c or whatever. Now, how do you do the same thing in Linux or Windows using Qt? This is one of the most popular C++ toolkit for GUI design. If you want everything is to be looking beautifully in a GUI, whatever programming we were doing in simple C++ language earlier, same thing in a different way it's done in a C++ on a GUI background in Qt. This is Qt screen. You can see a slot 1 is defined whenever you press a button. You can see that linserial is again used, and you used a message box also to display the final output. Similar kind of thing is done. You are writing into your file krdg question mark 1, then reading the data back and finally putting into a graphical screen like this, which was not possible earlier in simple C++. So Qt provides the GUI toolkit. Now how do you do read or create GUI in Windows? The easiest and best possible way is to use LabView. In the LabView you can see that you can create a screen like that, and the program is a graphical user programming. And here there is same thing you do. You can define the command to be sent, and there is a loop like bytes at port is a loop in which it will wait. The character will wait, and then you can see that visa read. Through visa read you can read the data. You can see that the response is plus 471.48 will be read. All those things will be discussed in the coming videos. Now, how to create an instrument? Suppose you wanted to create an instrument which can transmit some RS232 data. So you need to use a microcontroller. So microcontroller has got all serial voltages 0 to 3.3 volt or 0 to 5 volt. How do you convert it to a bigger voltage? For that you need RS232 chip. This is called level shifter, which is converting the one level plus 3.3 volt or whatever is there coming from a microcontroller into a minus 15 volt. That's a level converter. So this part will also be discussed in some of the videos in the next few these lectures. Now the last one, how to create an RS232 transmitter connected to a PC using ARM Mbed online compiler. There is a compiler called ARM Mbed online compiler which is free. You can create an account and write a C++ program to create the firmware for Mbed 1768, the ARM Cortex M3 1768 chip is used to program this. This is a very cheap and most advanced and one of the upcoming technologies. This is called mbed.com. You can log in and see. You can see the code looks so simple. What this firmware does is, a computer which is connected to the USB port of this particular chip, what it will do, that acts as a serial port link, virtual serial port through USB. One COM port will be formed after you install the driver of Mbed, serial drivers. You can see that as soon as you burn this code into the microcontroller acts as a RS232 transmitter. So what it does is, you can see in the main program, there's a while loop in which it says pc.putc in bracket pc.getc. That means whatever you type from the keyboard, it goes in the terms of pulses into the microcontroller, and microcontroller puts it back into the screen, same character. Suppose I type character A will go and come back. That means you will see two A's, and B will go and come back. So if you want, so right now there is no any message communication system. The only thing, whatever you are typing is coming back. Suppose when I type A, suppose my name has to come back, then I can program it accordingly using this language. And this is called ARM Mbed online compiler, and there is a separate video on detailed video on ARM Mbed microcontroller firmware creations using C++. This part will be discussed in the following videos. You should look at the following videos to learn the complete computer interfacing and automations. Thank you.